optimize the technologies going forward.
But that map, does that include Knoxville College as well?
I don't believe so, because, let's see, Knoxville College would be,
Around the edge there, right?
yeah, that would not be in the project area.
Too bad.
I want to focus briefly on some more detail about each of the key components on the smart meters. You've probably heard a lot about smart meters over the year, but basically digital electronic meters that will have two-way communication capabilities. Basically a card will be embedded or inserted into the meter that allows it to both transmit and receive radio signals, which will communicate the data back and forth to KUB. As a result of that, we'll be able to remotely read the meter. We'll be able to remotely connect the meter for service or even disconnect the meter for service, and all that can be done relatively instantaneously, as opposed to having to send people out in the field to do these events. With respect to the usage data itself, for commercial customers, the meter will capture the usage data every 5 minutes. For residential, every 60 minutes. And then the meter will also be able to capture power quality information. What's the voltage level going into the house? Has there been any flicker events in the last 60 minutes? Has the meter been tampered with as well? So power quality information will also come back to KUB that we can route into our various business systems to address any issues the customer might have. And then we talked about the home area network devices. We'll talk about that in a little more detail in a few minutes. But the key component of that is the smart meters communicating with those devices, so that inside the house, when you see your display, you'll know right then how much you've used for a given month, or at that point in time in the month, what's going to cost you if you got your bill on that day. So it helps you be able to adjust your usage. Any question on smart meters?
The actual resident person can go out there and look at the meter, and it's going to tell them how much their bill will be on that meter.
It would probably be in the kitchen.
Not
So
the
it'll be
meter
inside
itself.
Not the meter itself.
Okay.
You'll have a home energy display, and maybe this big. So if you set it on your table, you come down for breakfast or whatever, you can see how much you've used. And if it's the 5th day of the month, you could say, okay, I've used 200 kilowatt hours so
Upstairs, they're
far.
supposed to be asleep, and you see it.
Yeah, so at any point in time, you can see, if I got my bill today, that's what it costs.
Wow.
So
So
those are
for
pretty
each
cool.
of these 6,000 that we have, the person on the inside will have one of those when they do it?
Well, only the residential customers will be getting these, so it'll be approximately, I think, 3,000 in the pilot area that'll be receiving these. Yes, ma'am.
I know in the past, and this may have been when we first started the smart meters, that some of the smart meters actually weren't so smart. The calibration was off. So do you go back and double check these somehow, or, I mean, sample, you don't have to do everything. They may have improved a lot, but I'm just curious how they
Yeah, within the meter itself, it'll actually sample the data, I think, for residential every 15 minutes and such. But we will have what's communicated to us. We will be looking at all the data, so we'll be able to see hopefully if something is off. But we'll be working, as we roll this out, we'll be working with census metering systems to have troubleshooting programs
Yeah, I mean, I
in
just
order to be able to
just
detect any
continue to
issues.
back up to make sure it's really recording the proper.
On the communication infrastructure itself, again, it's two-way communication. The census metering systems, they have their own dedicated radio frequency, and that's basically what we'll be using. The meters, again, will have the device in them that allows to transmit and receive. So basically, at pre-scheduled times, that data the meter will send a radio signal, and we'll have these spread out throughout the system. Initially, we'll have 2. But it'll go to an antenna on top of, say, a cell phone tower, or maybe a KUB substation, maybe a KUB water tower. We haven't determined all the sites yet, but the data will go to the antenna. From the antenna down to the base of the tower, whatever structure it is, there'll be a server. It'll be about the size of a refrigerator. And from that server, it'll go via satellite to a host server. And right now, that census has that right now, and it's in Dallas, Texas. Hopefully, we want to have it at the Hoskins Center eventually. But so, and from there, it would be transmitted via web enabled software. KUB will get it at the Hoskins Center. And then it will be interfaced with all our different business systems, billing systems, outage management systems, GIS. So it's really going to be neat how the information all flows. But all that's, you know, in the time it took me to say that, it would have already happened. It could have gone back again. So it's almost instantaneous how the information will flow. With respect to the, excuse me, the meter reads, it will report all residential reads every 60 minutes and all commercial reads every 30 minutes. And on the power quality information, I mentioned that before, we'll get the voltage levels, we'll get flicker counts, but we'll also know, and we'll know this instantaneously, it doesn't rely upon the 60-minute interval. If the meter's been tampered with, an alarm will go off in our system, we'll know that immediately. If power is out, and this is really the key part, if there's an outage, we'll be notified immediately. And that information will be routed automatically to the outage management system so we can check and see what the cause of the outage. All that will get the customer's power service back a lot quicker. So reliability is a big advantage of this as well. If we wanted to do what we call an on-demand read or status check of a meter, we're curious about a specific household meter, we can do that in less than 10 seconds, basically. And the information, our request would flow to get that read and flow back to us through all that I mentioned earlier, less than 10 seconds. And then we talked about the remote connect, disconnect capabilities. No longer would we have to send trucks out in the field necessarily to put a boot on a meter or what. We can control that remotely with just a click of the mouse. Any questions on the communication infrastructure? I did have a diagram here also, just to illustrate my long-winded explanation earlier. But you can see at the individual residential's house, this is an electric smart meter, water meter, gas meter. Obviously the water would be in a different location. But at pre-scheduled times, via radio frequency, radio signal, it'll go to the tower. And again, this could be an actual cell phone tower, it could be a substation, still to be determined. From there, it would go to, this would be our server located at the base of the structure, then to the network or AMI head end, and then on to KUB. And then if we wanted to, say, disconnect service for whatever reason, it would work the same way, back down but just seconds for that to happen. So, pretty neat. Distribution system automation. I know Mike Patterson talked in some detail about this several months ago, so I'll just briefly go over it. We talked about creating the fiber optic communication loop between all the substations in the pilot area. One key to that, and we'll use that communication system for, in all three of those substations, we'll be installing voltage regulators, which basically will allow our system operations folks to monitor the voltage and look for what the ideal state would be. If it's too high, they can lower it. If it's too low, they can raise it. And all that will allow us to have a more efficient flow of electricity throughout that area and ultimately save system losses, save costs. We wouldn't be buying as much power from TVA as we otherwise would have. So again, a measure of efficiency there. We'll also be installing faulted circuit indicators on our distribution lines throughout the project area, and I think about 240 will actually be installed in that area. And they will work basically the same technology as the meters. They will communicate via tower back to KUB. And through to KUB, it would go to the outage management system. So again, our system operations folks will know where to go to fix the outage. And again, it gets the customers back in service more quickly than it is currently the case. So